Alrighty guys, let's go ahead and take a look at these weird unit conversion challenges. So we have multiple challenges here. We have 1, 2, and 3. We're going to do all 3 of them, even though I only need you guys to do 2. So the first challenge says, how many Oreos would you need to stack to reach the height of the Sears Tower? And for those of you that are young, as I realize every year that is more and more of you guys, that just means the Willis Tower. But for us oldies, we're always going to call it the Sears Tower. So after a quick Google search, you'll see that the Sears Tower has a height of 1,729 feet. And after you do some quick Googling as well, you'll find out that the standard Oreo, we're just doing single stuffed here. I know there's single, double, triple, Shrek Oreos, but we're just going to do single, is 9 millimeters thick. So we want to figure out how many of those Oreos is it going to take in order for us to reach the top of that tower. So let's start off with the height of our tower, which again is 1,729 feet. And we want to find a way to go from feet into Oreos. So we know that Oreos, though, have a thickness of 9 millimeters. So one Oreo is equivalent to 9 millimeters of thickness. So how can we go from feet into millimeters? Well, we can first go from feet into meters. We know that 1 meter is going to be equivalent to 3.28 feet. And since we had feet on top here, we put feet on the bottom there. Next, we can go from meters to millimeters. We know that if meters is on top here, it's going to go on the bottom here. And 1 meter should be equal to 1,000 millimeters. Lastly, we have millimeters on top here, means we need millimeters on the bottom here. 9 millimeters, well, 9 millimeters is the thickness of 1 Oreo. So all we have to do is make sure our units cancel out. Feet cancel out with feet, meters with meters, millimeters with millimeters, and we're just left with Oreos. Now we just multiply our way through. 1,729 times 1 divided by 3.28 times 1,000 divided by 1 times 1 divided by 9. We find out that it should take approximately 58,570 Oreos. The next part of this question asks how much it would cost. So if we quickly look this up, and I'm going to do this in another tab, Target or Walmart's the first one that pops up. Not endorsed, not advertised. But Walmart has a pack of Oreos for $4.58. And there are approximately, let's see how many Oreos come in this pack. It says 15 serving size 3 cookies. So 45 Oreos for $4.58. Go ahead and write that here. 45 Oreos at $4.58. And that's assuming there's no tax, and we can assume that because we're a school, so we have tax exempt. So in order for us to figure out how much it's going to cost, we could find out the cost per Oreo really quickly. So by doing that, we can go ahead and take the cost and divide it by Oreos. So $4.58 divided by 45 Oreos is going to give us an average cost of 10 cents. We'll just round up and say 11 cents per Oreo. All right. So all we need to do now is just take our number and multiply it by the number of Oreos we have here. So 11 cents times 58,570 Oreos. And that means it's going to cost us roughly around $6,442.70 in order to fund this project. Alrighty, let's take a look at problem number 2, which is how many pencils placed end to end would it take to reach around the globe? So this one is a lot bigger, I would think, because the world is obviously a lot bigger than the Sears Tower. So if we found out how long the world is, like if we were to wrap a rope around it, we find out that the circumference of the world is 24,901 miles. Okay. So after we find that information, we probably want to find out how long a pencil is. And after, again, some quick Googling, we find out that the average pencil length is around 19 centimeters. All right, so challenge number 2. So let's go ahead and start off with 24,901 miles. And our goal is to get to centimeters at the end. Well, technically our goal is to get to pencils, but in order to get to pencils, we need to get to centimeters first. So how can we go from miles into centimeters? Well, first thing we can do is go from miles into meters. We have miles on top here, means that we want miles on the bottom here. 1 mile is going to be equivalent to 1,609 meters. Now that we have meters on top there, we need meters on the bottom here. We know that 100 centimeters is equivalent to 1 meter. And then lastly, we have centimeters on top there. We want centimeters on the bottom here. 19 centimeters is equivalent to 1 pencil. So let's make sure everything cancels out. Miles cancels out with miles, meters, meters, centimeters, centimeters. We're just left with pencils. Awesome. So now all we have to do is multiply our way through. Once we do that, we end up with a pretty big number here. So I'm going to use scientific notation to help me abbreviate it. I get 2.1 E8 pencils. So lots and lots and lots of pencils. I know it doesn't ask for this, but we already did it with the Oreos. Why not figure out how much it cost in pencils to do that? So let me just do another quick search for pencils, and I already have Walmart open, so I'll go ahead and use Walmart as my reference of price. Let's just do these really cheap pencils. So 24 pencils for $1. Okay. So 24 pencils, and it is $1 for that. So the average price per pencil would be $1 divided by 24, which gives us an average price of about 4, but we're going to round up again to 5 cents per pencil. So 5 cents per pencil. Okay. So we know how many pencils there are here. All we have to do is just multiply that by 0.05, meaning 5 cents. So 2.1 E, and if you don't know how to put this E in your calculator, we can talk about that more in class, times 0.05. That's going to give us a price of, lots of zeros here, of $10,500,000. So a little bit more pricey than the Oreos, but I mean, still affordable. I think it's something we could possibly fundraise for in the future. All right, let's take a look at our last problem here. This is how many boxes of Jell-O would it take to make enough dessert to fill a 375 cubic meter pool? So this is definitely the hardest problem on here, and there's multiple ways to approach it. But the first thing that we have to do is figure out, what does a box of Jell-O tell us? Like, how much Jell-O, how many cubic feet or cubic centimeters or whatever, how much volume is there out of a box of Jell-O? And the general box of Jell-O is going to give us 2 cups worth of Jell-O. So that means that we have a starting point here. We now know how much we can get from a box of Jell-O. So 2 cups, though, we're going to need to convert that into something that's going to help us out more with the units that we were given. And the units that we're given are cubic meters. So we got to figure out a way to get cups into cubic meters. So I know that there are 236 milliliters in 1 cup. So that's my first step. Now that I have milliliters, I can go ahead and convert that into centimeters. And we remember from before that 1 cubic centimeter is equivalent to 1 milliliter. Now that we have cubic centimeters, we can go ahead and convert that into cubic meters. 1 cubic meter is equivalent to 100 cubed centimeters cubed. So this is the super important step where people mess up on. Because we know from the past, and I'm just going to go ahead and write that up here, that 1 meter is equivalent to 100 centimeters. But 1 cubic meter means that we have to cube all of this stuff. So this, I'm just going to translate over here so that we can see, is 1 cubed meters cubed over 100 cubed. 100 cubed is obviously not 100. It's a way bigger number than that. 100 cubed is 1,000,000. So that would be 1,000,000 centimeters cubed. So I'm just going to replace this with this guy here. Okay. And now we have centimeters cubed. So from the centimeters cubed, though, we still have a lot of other stuff we need to get to. But let's quickly just kind of simplify this part here. So cups, cancel out with cups, milliliters, milliliters, centimeters cubed, centimeters cubed. If we do that, it's going to take me a second to multiply it. I get 2 times 236 times 1 divided by 1 times 1 divided by 1,000,000. That's going to give me 4.72 e to the negative fourth meters cubed, which makes sense because it's not really giving me a lot of cubic meters of Jell-O. So this is how many cubic meters of Jell-O we get per box. So now that we have this conversion, we're basically done. And if we go back to how we started, we have 375 cubic meters of a swimming pool we need to fill. And the question is how much Jell-O goes in it. So here's our conversion that we need because we're supposed to finish with boxes of Jell-O. Therefore, these cubic meters go on the bottom and boxes go on top. This is over boxes, so that's just one box there. And it's 4.72 e to the negative fourth. So if I do 375 divided by 4.72 e to the negative fourth meters cubed, it's important that this is in parentheses so we don't mess up this problem. We end up with a final answer of 794,491.5 boxes of Jell-O. And why not? Just because we're already here, let's figure out how much that costs. Back to Walmart. So it says 2 cups of Jell-O should cost about $0.785. So in other words, it costs this much per box. So all we're going to have to do is take this number and multiply it by our final answer. So 0.785 times 794,491.5. We find out that this is going to cost way too much money, which is $623,675.83. So still not as expensive as the pencils, but way more expensive than the Oreos.